Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Starship Flight 9 and some extra updates. So let's dive deep into it. So this mission had certain lofty goals, let's just put it that way. So it was first ever reuse of previously flown booster. While SpaceX have catched this puppy, but you have to understand, whenever you do the first catching or the first landing, you do not reuse it. You're just like you decommission it and you figure it out how the heck it went. Basically, metal fatigue structures, things of that nature. So, and again, same was done with Falcon 9 booster. The first one that landed, they did not just like, okay, let's refly it. That's not how it works. So it's a big milestone to like, okay, catched it, cool, let's launch it again. So this let's launch it again supposed to happen in this. Now they are improving the flip maneuver. Basically, when this puppy detaches from the Starship, right now it's just hopes and dreams. They are trying to with grid fins, but it's not as precise, as directional as they want it to. So they have changed the exhaust structure, meaning the vents, they have sealed certain vents. So basically it's acting like a miniature rocket going. So they should get the exact thrust exactly as they need it. So it should supposed to save them propellant in terms of booster. So basically booster can go all out for longer, giving more delta V to Starship. And because they are consuming far higher propellant, they have steeper re-entry. Basically, they want to maximum drag out from the atmosphere point of view. Penalty, it heats up. Benefit, it does not need to decel so much. It's like majority of energy can be taken out by the atmosphere, and then you just do easy decel. And they also wanted to test engine out capability, meaning while they are trying to do chop stay, they will eat one of the engine and they're like, okay, now figure it out, how can you handle it. Technically, computer should be able to compensate for that. So because of all these things involved, they made sure that they're not going to catch it. They're just like, okay, splash it into Gulf of Mexico or Gulf of America. And they're also supposed to, in Starlink, they're also supposed to deploy dummy Starlink payloads, meaning the things that have the size and mass of original Starlink, and they're just supposed to yeet it. Basically, yeet system they have to test, and hopefully don't go boom, because they have already went to boom 2 times. So that was the hope for Flight 9. So Flight 9 happened on 27 May 2025 on 23:36 Universal Time Coordinate, and takeoff was good, it was smooth, and then the hot staging, it was good, smooth control, and they got exactly what they were looking for. They were looking for certain sort of torque motion, and they got that. Everything is fine, everything is dandy. And then it started to go through that max decel, and then ignited the engine, and then it just went boom. This is from Tim Dott's live stream. He actually had a telescope, but the atmosphere was too hazy. So the best you can say is just like puchut. So it was atmosphere's fault, not that camera was not there. If atmosphere were clear, people would have easily seen it. So basically, it did not work out. And then Starship engine went to second engine cutoff, which is good. And then the payload door failed to open, and it also started to spin off. And there was some venting, and there was a lot of problems. And then it basically lost all the control, started tumbling, and then it directly did re-entry. That's why it's like going. It's literally doing like that in atmosphere. Although, let that be very clear, this is not good. But this does prove, beyond a shadow of doubt, whoever the hell is the engineer for Starlink communication bridge, they know how that works. Like the system can maintain data link in this environment. Is like, shut up, take money. Shut up, take money. That is like, how the heck in a plasma stream you're successfully maintaining this? It is like, damn. Like, trust me, it's not an easy thing. And again, satellite dishes, when you are spinning is hard. Satellite dish, when you are spinning on an object that is spinning in all axis, while you're going through a plasma stream and you still have communication, I'm like, damn. So that is good. So what are the issues here? Well, at this point in time, this is really bad, because it's reaching the old days of SpaceX, where they had 3 consecutive booms, or going even back to basically Soviet Union, the moon rocket going boom 3 times in consecution. So it's a rare thing. Like, trust me when I say this, it's not, oh, every Tom, Dick and Harry has to have 3 booms consequently before they have a working rocket. That's very rare. So this is not a good thing. And what does it prove? It proves the patchwork is not working. They're like, okay, we changed this to make sure this does not happen, this does not happen, this, yeah, all of them happened. So something is serious design flaw is there in V3. It's like, it's just not working out fundamentally. And all the issues are happening in this section. For all last 3, either something broke off here, fire happened here, pogo oscillations happened here, something is happening in this area, in this design, because it was not happening in the previous design. It's kaputting the whole system. again and again. It be it, and they're like, okay, we're gonna do fire suppression, does not work. We're gonna do pogo suppressions, maybe it worked, but again it still went to boom, so let's assume it did not work. So things are just not working. Like, it's just like, no, it's not working. And most likely pogo oscillation is the primary source. That's the best guess people have, is that you have propellant sloshing too much and creating oscillations, and computer is trying to compensate for it, and it's creating cascade loop, so to say. And it's mostly because of design changes. Basically the header tanks, how the heck the piping is there, that is changed compared to version 2 and previous variants. In this, the piping has changed. So the only thing that changes, because if you change piping, is splash. So this is serious issue. It's like in modern day and time, even small startups, they generally do not go boom 3 times, one after the another. And exactly the same way, it's like, okay, this happened, that happened, but all of the issues always starts here. All of them. It's like always something is going on wrong here. So this is a serious issue. Now, you have to understand, SpaceX strategy looks very wise from outside, because we have been seeing the good side of it. But this is the penalty of it, because it's a high risk, high reward scenario. And it's almost like investment when you're like, you're older and you're poor, and you're like, oh, I should have invested. But then you're like, why didn't you invest it? It's like, that time it was scary. And the same thing rule applies here. They are changing way too many things too quickly. Meaning that, like, whenever Elon Musk interview is done and he's on the rocket garden and all that, is like, yeah, we have done 1000 changes. Yeah, that is good, but it does come with a penalty. If it works, it allows you to do rapid development, meaning your development cycle would be exponentially faster. It not only applies to hardware like Starship, it also applies to software, but it also comes at a cost. You have increased your risk exposure exponentially. You do not have mild risk anymore, you have maximum risk. And if you get stuck in what we call confounding variable problem, God help you. Like, that has happened, because that's why whenever you're developing a program and you're supposed to do it right, you're supposed to do minimum viable product. Then you're only supposed to add one thing. Then you're supposed to test the hell out of it. Then brick by brick, day by day, you build on it. Now, like, it's a slower thing. Yes, absolutely. But it also makes sure that if kaput happen, which does happen, you can roll back, figure it out, what went wrong, and then fix it. So this, like, move fast and break things, it has penalty, so that risk. And another aspect of it is that world's biggest rocket is not isolated enough, meaning it has very high consequences zone, and consequences not limited to SpaceX alone. The consequences affecting other things. This should not be a normal scene where a commercial airline pilot is like, hey, what the hell, that fire? Oh yeah, that's Starship going kaboom. So that's not a normal thing. It's not isolated enough. It's not like, okay, I'm going boom, kaboom, kaboom in bunker. It's not like that. You are literally have and again, the size and the mass is so huge. The cast area is magnificently huge. This is the penalty why SLS cannot do work like this, where it's like, what if we change this? What if we change that? If they have to change it, it's like, okay, only change the damn one thing. Be damn sure that we have not tampered with anything, because again, confounding variable problems are like, even ask mathematicians how horrifying that is. Like, it just does not work. So what options they have? Well, at this point in time, assuming even the fourth one goes boom, they should strip everything and focus on the booster, because booster is the closest to actually working. So we really should focus on booster. And here's the deal. Is there a tangible economical benefit to doing so? Yes. If you have a working booster and you just strip all the bells and whistles from Starship, Starship will gain extreme capability, meaning it's going to go from, let's just say mathematically what they are shouting, 100-ton to low Earth orbit, to almost 200, or maybe even more than that. That is shut up, take money, like flat out. For many things, it's like shut up, take money. So they can still have that, like, focus on the booster, get the system rolling, because again, after 9 launches, still haven't thrown payload in orbit. Even the investors have upper limit. Like, So this high risk, again, now you're getting it. Why not everybody tries this high risk approach, so to say? And again, it should not be approached when you do not have isolation. When you're like literally, hey, airlines, you have to divert because one rocket went kaboom in some wrong place. Yeah, that's not a comfortable thing. Once in a while, cool. Once a year, not cool. So what about the Elon Musk update that he did? He's still talking about Mars, and I am still shocked, confused. how the heck is not updating? And I'm like, I'm old enough where when he was actually smoking, so I do not know what he was smoking back then. He was like, we're gonna have the Dragon capsule landing on Mars. I'm not joking. That look it up. Like it is long ago. Like I used to be a 3D game artist back in the days, and it's like we're gonna land by 2020. Like 2020 came and went, man. So that design stupidity is the exact same thing where we're gonna use Starship to do. Again, can we do Starship missions to Mars? Yes. Is it wise to do? Again, for small scale, absolutely. But if you want to actually ship a people, that's not how you do it. It's almost like, oh, I have a company that is making a stuff, let's just say fans. They're making fans for me in China's factory. They're gonna ship it in a shipping container. But here's still, that shipping container is not gonna sit on a boat and then come to me. It's gonna get collected and set into a giant shipping container. Only then it can be shipped economically. Same thing applies whenever you are trying to do what we call planetary transfers. You're not supposed to build a craft that goes from surface to surface. You're supposed to build a craft surface to docking to surface. That's it. And they're supposed to be a big craft, almost like how they showed in the movie Martian. And again, if you have 100 ton to low Earth orbit or 300 ton to low Earth orbit, you can build a massive craft. You can have massive water barrier, so your radiation exposure would be minuscule. And you can even have spinning habitat, which again, it also allows you to actually have basically food, sex, pooping, peeing properly, and people will not degrade as much. So that's a proper way of doing it. Not this, what if we launched 1000 of that? Like, yeah, you're just burning propellant. It's inefficient. You're supposed to have multiple craft on that ferry, so to say, and that ferry is supposed to go back and forth. Never basically go slow enough where they get captured by either Mars gravity or get captured by Earth's gravity. It should always be in the system. And some designs have as fast as like 9-month transfer windows, not 2 years. So that's why, like that, every mathematician has figured it out. Like we had figured this out like long ago, like 1990s. By basically 2010s, people are actually giving, okay, we can build this sort of craft. We can use ion engines, so we can have continuous acceleration. A lot of things can be done. So I have no idea. It literally looks like you're doing the exact same thing you were doing in the early days of Mars 1 mission. So, and the target is 1000 ship per year, which translates to 3 per day. Why? And again, this, even if it's only as reusable as Falcon 9, that Falcon 9 is now stretched to almost 25 launches reliably. That's a lot of reuse. Why the heck? And again, you are also reusing everything else. Why do you need that much? Like Starlink does not have that kind of bandwidth requirement. Like, yeah, you can launch it, cool, awesome. But here's the deal. Starlink is a showcase that USA has a lot of corruption. Like under no circumstances, Starlink should be as big of a deal as it is right now in USA, simply because US government paid a lot of money to all telecommunication companies. Please apply fiber link. And again, there were a lot of people, it's like not enough of them that company will do fiber link extension to themselves. And again, that's a sparse country, so they did not have the luxury that India did, where everybody got fiber. And there are certain places where you will not have that reach. But it should not be a normal thing where everybody is like, oh, we need satellite internet. If that happens, that simply means you have fundamentally messed up, and especially messed up given the fact that government was burnt, I think, $1 billion a year for a few years. Please give fiber, and companies are like, no fiber, no fiber. So there is a fundamental limit how much Starlink can be sold. You can sell it to every aircraft company. You can sell it to every cruise ship company. You can sell it to basically anybody who's on the water, anybody who's in the air. You can sell to them. But that's not that many people. Like really not that many people. And what about population centers? China has a fiber. India, you come to India, my man. We have fiber on top of fiber with some extra fiber. We're good. And again, imagine if some other company is like, okay, what if we actually start to do the fiber thing? So scope-wise, 1000 sheep consumption per year is like, eesh. Especially with a reusable design, it's like, why? And it's like, we're going to launch thousands of them to Mars. It's like, yeah, you're just going to go bankrupt on the fuel consumption alone. That's why you're supposed to build a giant ferry. And removing that pie in the sky idea out of it, there was showed a new hot staging design. Now this looks Russian. This is like literally how Russian moon rocket looked like. So this strut design, they had a mock-up next to him. So the strut design will allow them to have less weight, more strength, and they do not have to yeet it while landing. Because again, booster is the closest thing they have that is working. So this is how they are refining the booster. Now, another aspect of it, like how much propellant it can carry, what is the height, all of them are floating. Leather Vega is like, it can take this much, but we're going to increase it. It's going to take this much. I think that's why China cannot copy it. It's like, okay, what is the design document? To be decided, to be decided, to be decided. Everything is TBD. So that's not working. Orbital refueling, they are talking very seriously about that, and that's supposed to happen before this year is out, as in 2025. It should be done. And all hopes, right, practically speaking, all hopes is now lying on this puppy, which is Raptor 3. Now, the primary reason why they're focusing so much on Raptor 3, it's actually manufacturable en masse. Another is because it's so simplified, the fire hazard is minimized. And again, given the fact that they are having so much fire issue, that's a good desirable thing. So all their hopes, like remove everything else. What is the core essence? Core essence is this puppy should work. If this does not work, kaput the whole program. It has to work. And let's see how it unfolds, so to say. But again, I'm like still like Mars, like that's not how you're supposed to do it. Like imagine in a future where every shipping container literally has a small boat that is shipping it. You'll be like, what kind of cocaine you are doing, my man? But it is what it is. But this strut design is wise, and all hopes on this. Nothing other than that was worth said there. So this was my presentation on basically update on SpaceX current endeavors, so to say. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.